So greetings students. So today we will be determining your motor parameters. Especially we will be dealing with your various tests which are performed over your induction motor. Okay. So coming to the topic, due to similarity between your IM induction motor with the transformer, so the same test what you are performing over a transformer is applicable to your induction motor also. Okay. So here the test what we'll be doing a DC test to determine your stator resistance R1, followed by a no load test. Okay, for determining your rotational losses and magnetization current. Then locked rotor test. So to determine your stator and your rotor impedances. So starting with the DC test, so you have to know the purpose of doing the DC test. So this DC test is to determine your R1, that is your stator resistance, a variable DC source. Okay, this DC source is a variable DC source. Okay, is connected between the two stator terminals. Okay, the DC source is adjusted such that to provide nearly your stator current. Okay, nearly the stator current has to be provided by this DC source, and the resistance between the two stator leads is determined from the voltmeter and your ammeter readings. Okay, based upon this readings, your stator, what you can say, your stator current will be determined. So then your RDC is equal to your VDC, that is your voltmeter reading divided by your ammeter reading. If the stator is connected in your star, if it is a star connected means the per phase stator resistance is given as R1 by R1 equal to this RDC by 2. Okay, so your RDC will be twice the value of your stator resistance. Okay, but in case of a delta connection, now for the star connector we have said, but in case of a delta connection, this value changes to R1 equal to 3 by 2 times of your RDC. Okay. So in case of a no load test, so you already know this no load test, we won't be connecting any kind of load to the system, and the motor will be allowed to spin freely without any kind of load. The only load on the motor is your friction and your windage losses. So all the converted is consumed by this mechanical losses only, because here there is no kind of load. So all the converted power will be given to your mechanical losses only, that is your frictional and winding losses. So the slip value is also very small in case of a no load test. So here at this small value of the slip, your R2 1 minus S will be equal to R2, and your R2 1 minus S by S will be equal to X2. Okay, so the equivalent circuit will be reduced to in this format. So here you can clearly see that your load will be more or less equal to the resistance of your friction and winding. Okay. Here at the no load condition, the input power measured by the meter must equal the losses in the motor. Okay. So the input power, here there is no output power. P out is 0. So here only the losses are considered. Only the losses are considered. So your rotor copper loss is negligible, as your I2 value is very small. If you are connecting your load means only there will be the flow of I2. In case if you are not connecting your any load means there will be the I2 value will be very low. Okay, so the input power will be equal to this format. So here the P core and then this frictional winding. So the equivalent input impedance is approximately is approximately uh, is approximately equal to Z equal to Z equivalent equal to B phase by I1 NL Okay, so this x1 can be found in by your magnetizing impedance xm. So coming to the blocked rotor test, in the blocked rotor test, your rotor will be blocked. That is, your rotor cannot be able to move. Okay. So voltage is applied to the motor, and the resulting voltage and current will be measured in your blocked rotor test. So the AC voltage applied to the stator is adjusted so that the current flow is approximately full load value. The locked rotor power factor is found out by this formula. Okay, it is nothing but your input by your output power. Okay, so your total impedance is V phase by I. So your blocked rotor test is equal to ZLR equal to RLR plus J XLR dash. Okay, so this is what you will be getting. So these are the design parameters that you have to consider in case of your blocked rotor test. Okay, thank you.